Hey everyone, welcome back to Beyond Prompting. I'm Banana.
And I'm Orange. Happy Saturday. Today we're talking about something that kept me up last night. A new Princeton-led study that handed frontier AI agents 6 days, $3,000 in API credits, and 2 real unpublished research questions. Then watched them fail. Every single paper they produced was rejected.
Rejected by the actual scientists who came up with those research questions. That's what makes this study different from every benchmark you've seen. Let's break down what happened and why it matters.
The timing is wild. OpenAI's Sam Altman set a public deadline, a working automated AI research intern before September 2026, announced during a live stream in October 2025. At publication, that deadline was 32 days away. So this is the first empirical test where the frontier agents can do what that intern would need to do.
And the answer, as of late July 2026, is a pretty emphatic no. But here's the twist. The agents were incredible at the engineering. They wrote LaTeX, debugged GPU clusters, ran hundreds of experiments, and delivered camera-ready papers with no human code. The engineering gap? Closed. The research judgment gap? Wide open.
Let's get into the method, because this is genuinely clever. The team calls it shadow evaluations. The agent shadows an original research effort. It gets the same research question the human authors tackled, but no access to their paper, findings, or method.
3 properties make this different. 1, the questions come from real, unpublished papers, so agents literally cannot have memorized the answer. 2, the graders are the scientists who originally asked the question, the most qualified experts on Earth to judge whether real progress happened. 3, the task is genuinely open-ended. There's no automated rubric because the question doesn't have a verified answer yet.
They partnered with the authors of 2 NeurIPS 2026 submissions that weren't yet public. One was about the structure and controllability of large language model personas using weight space interventions, the personas paper. The other was about designing a distribution shift detector for tabular foundation models, the TabPFN paper.
And the setup was generous. Each agent got the research question, a Linux virtual machine in AWS, the same datasets and code the human authors used, an AI self-review subagent running against a NeurIPS rubric, external review tools including the Stanford Agentic reviewer, and $3,000 in Anthropic API credits plus GPU compute. 6 days to produce a paper worthy of a top-tier conference.
The main runs used Claude Opus 4.8 with extra high reasoning on a scaffold called OpenClaw. The results? The Personas paper scored 2 out of 6, reject. The TabPFN paper scored 1 out of 6, strong reject. Reviewers rated their confidence 4 or 5 out of 5.
And the reviewer comments are brutal. David Africa from the UK AI Security Institute wrote that the experiments were, I quote, bizarre and hard to understand, with results that seemed clearly post-hoc. Viet Nguyen from the University of Toronto flagged a proof-by-example fallacy. The agent tested a few unsuccessful approaches and concluded none could work. Both said the writing was dense, hedged, impossible to tell noise from signal.
The team didn't stop at one scaffold. There's always the objection that results just reflect a specific framework. So they reran the TabPFN experiment with OpenAI's GPT-5.6 Sol and its native codec scaffold. Same budget, same timeline.
Same result. It made no novel contribution and submitted misformatted figures. It even failed differently. It blew through the entire $3,000 budget in just over 2 days, leaving nearly 100 hours with no tokens. 2 models, 2 scaffolds, same research quality failure.
The log analysis identifies 5 recurring failure patterns. Number 1, poor publishability judgment. The Personas agent planned 48 hours of exploration before committing, then coalesced around an approach after just 5. Both agents settled on their weakest hypothesis and presented underpowered negative results as findings.
Number 2, uncreative problem solving. When the AI self-review tools came back with weak reject in all 10 rounds of the TabPFN run, the agent added caveats and narrowed claims. It never redesigned the experiment, never abandoned the approach. The hypotheses just grew narrower and less interesting as it discarded each one.
Number 3, ineffective backtracking. The agents could rerun an experiment or tweak parameters, but never backtracked at the project level. The TabPFN agent falsified all 6 of its initial hypotheses within the first 14 hours, then kept going for another 110 hours on the same negative results framing.
Number 4. Poor resource awareness. The Personas agent used 37% of its API budget. The TabPFN agent used 41%. One agent declared completion 7 hours early, while its own self-review still said weak reject.
And number 5, instruction drift. Over a week-long run, the agents increasingly ignored explicit instructions. Both papers blew past the 9-page NeurIPS limit. Neither used the paper polishing credit they were given. The team attributes this to context rot. Agents must actively manage their context window on multi-day projects, and current models don't do that reliably yet.
So what does this mean? First, it's a direct hit on how we measure AI research capability. Benchmarks like SWE-bench, MLE-bench, and EXP-bench test tasks with known answers, and any task that can be graded automatically can be optimized against during training. On EXP-bench, 461 tasks from 51 top-tier papers, the success rate on complete experiments across frontier models was 0.5%, with known answers. Princeton tested what happens with genuinely unknown ones.
Second, it's the first rigorous evidence about the assumption behind rapid AI progress. Forecasts like OpenAI's September research intern target and Anthropic's When AI Builds Itself assume agents will automate AI research, creating a self-reinforcing loop. This study says that loop depends on open-ended scientific judgment, and that capability hasn't been observed yet in a rigorous evaluation.
And third, this is a methodology we'll see a lot more of. The Crux project plans new shadow evaluations every 1 to 2 months, releasing all expert reviews, agent logs, and code publicly at cruxevals.com. The coalition spans Princeton, the UK AI Security Institute, Georgetown CSET, Johns Hopkins, Stanford, and UC Berkeley, built for independent governance, not industry benchmarking.
One contrast that stuck with me: the same group's first evaluation had an agent autonomously build and ship a functional App Store application for $1,000. So the takeaway isn't that agents are useless. They're closing well-specified engineering tasks fast, while open-ended research judgment remains the bottleneck. Point agents at well-defined engineering problems, and you're on solid ground. Expect them to decide what research is worth doing. September deadline or not, that's still a human job.
That's our Saturday deep dive on the Princeton Show evaluations. If this got you thinking, drop a comment. We read every single one. Subscribe so you don't miss tomorrow's episode, and we'll see you then. Keep building.
Cheers.